Hello, this is Sumit Sadgir from Mission 205, and I am Greenhouse Chief for this mission. I am currently pursuing my PhD and I am passionate about space and sustainability. My specific interest in uh, space mission is for growing plants in space using aeroponics and hydroponics for supporting long-term human habitation beyond the Earth. Then these are the highlights of our presentation, starting from the internal design to the sustainable goals SDGs. And uh, for first time we start with internal design. Then it includes main station, greenhouse, power station, health center, engineering center, launch center, and sanitation center. So main station will include artificial intelligence based weather data. So the all the crew members in the main station will get weather data in real time using the AI and the sensors. Then there will be emergency safe room. Uh, so we know that during the space missions, emergency can occur at any moment. So we will have this room. So crew will be safe in this room during the emergency. Then we will also include AR displays to show the real-time data on the screen using augmented reality systems. And also for the crew, we will use virtual reality-based simulations in the main station. So next one is the greenhouse. In greenhouse, we will use vertical farming as we know during this any space mission, storage is much important, and vertical farming is one of the best method for the storage of the plants. And then the method used will be aeroponics and automated nutrition, as both of them when combined, it gives maximum efficiency for the plants and the entire system. So along with this, waste recovery system will be used in the habitat. So the heat that is released by the habitat can also be utilized to regulate the plants. Then for self-sufficient food production and sustainable life support crew members. So speaking about self-sufficient food production, plants will be grown in control environment using the artificial intelligence. Actually, the uh, plants will be monitored continuously by the sensors, and AI will analyze the data and provide the best suitable environment for them. And this aims to reduce dependency on resupply missions from the earth, as we can't uh, carry plants or food every time in every mission. Then talking about aeroponics and nutrient systems. In this system, nutrients are directly given to plants' roots through a fine mist. So, as in hydroponics, we supply nutrient directly into the water solution, and in this aeroponics, the we use mist. We mix the nutrients on the plant roots. So this conserves water, promotes rapid growth, and ensure a stable food supply. So in the power station, uh, just using solar or actually nuclear reactor need more size. So I am choosing RTGs. RTGs is radioisotope thermoelectric generators. It's a radio decay based system in which radioactive materials loses their energy and they transform it to other elements. So in this process, heat is released, which can be uh, used for the purposes, mission purposes. Then, for example, in the NASA rovers, the plutonium-238 radioisotope battery is used. Then, unlike lithium-ion batteries, it have long lifespan of about 20 to 25 years. Then it is also portable, so we can carry it from one place to another. And also, the main benefit is the lithium ion batteries fluctuate. So, actually, RTGs provide continuous, constant energy flow. So, we can avoid fluctuation and our systems will be more stable. And also, along with this hybrid system of solar and RTGs, we will use biofuel generators. So the organic waste will be converted into energy. Then in health center, we will include portable diagnosis kits. Then also for VR technology, virtual reality therapy will be used in the uh, surgeries for simulation purposes. So we can improve the precision for the surgery and other medical requirements. Then also we'll use robotic assistant to provide real-time health report. For example, uh, a crew member had some health issue, so the system will analyze it and the data will be sent to all other crew members. So also in the form of emergency notifications. So the further procedures can be done. In engineering centers, 3D printers will be used, which will be mainly do functions like printing machine components, space mission materials, and habitats using Martian regolith. So generally, right now there are many companies which are printing uh, entire habitats using the Mars regolith, and so this can be further uh, used in the space missions. And then these are NASA JPL robots, which NASA is currently working on. These are autonomous repairing bots, so they can also repair the habitat on their own and also provide real-time status of the habitat to the crew members. Then in the launch center, we will use drones and Mars helicopters with to reduce the work of crew members. At every time, we can't uh, give the every task to crew members. So some task will be done by drones and Mars helicopters, and which will be they will be their landing will be based on artificial intelligence. Then we will use rapid inflatable structures. So we can't carry our complete habitat as it is in the full size. So we'll use this system. So it's packed in the small size, and whenever it's required, it inflates and comes into the actual size. So we need less storage during the transportation from Earth to the Mars. And then this is sanitation center in which we will use closed water recycling system. It generally captures water from the urine, sweat, and other parameter, and then it filter and processes it to give the clean water. It's used in ISS, International Space Station, and later be used for drinking or hygiene purposes. Also, we'll use biogas regeneration system. The organic waste, whether it be from humans or other birds, it will be converted into fuel. And then self-cleaning surfaces, which include microbial coatings to provide so they are no need of cleaning time to time. It will be automatically cleaned. This is the organization structure of this entire members. So first one is mission commander, which is the lead role. Then there is a science operation officer for the scientific operations. Then engineering officer, officer, and operational specialists. So all of them have their specific responsibility to contribute toward the space mission. Then this is the position and profiles right now for the Habitat Mate. Coordinate is Razan. Then engineering chief is Valentina. Greenhouse chief is myself. Launchpad chief is Anais, and power station chief is Jess. So before going to the space mission, astronauts will be trained through the astronaut training programs. So crew members will undergo extreme pre-launch trainings that includes following things. Botany, robotics, and emergency. Even if the one astronaut is botanist, but he needs to know about robotics and all other things. So he also, in case of for example, one astronaut who is one crew member who is only or is busy or can't perform his activity, so the even other member can do his activity as he is trained for that. Then we will use virtual reality simulations, gyrospins, psychology test, and all other activities to train astronaut. And crew will be updated with operational protocols. This is the YouTube videos, which will be uh, the playlist will be made before the mission and will be provided to the crew members. And during this, so it will be used for training refreshers and emergency procedures. Then their mental health and relaxation. Educational content will be provided. They can also include entertainment like movies, documentaries of their choice, then exercise guidance, communication, and DIY repair videos. So these are the resources required for 1 week. So obviously we will need food and water. So averagely, a crew member needs 40 kg of packed food and 20 liters of water along with nutritional supplements. Then these are the hygiene supplies like wipes, shampoo, toothbrush, razors, and other products. So also we'll need medical supplies. If any crew member has some medical issues, so he will need his personal medication and general first aid kits. Then clothing, sets of garments, exercise outfits, and thermal suits, etc. This is the water and nutrient recycling system. We all know that water is the one of the most valuable thing during the space mission. So in this system, uh, we will recycle moisture of the environment and waste and convert it into usable water for the plantation, which we will use in aeroponics. This enhances the sustainability by reusing nutrients from plant waste, minimizing the need for external inputs. So these are our Sustainable Development Goals (SDGs), and there are total 17 SDGs as by UN. But and this mission supports all of them, not just two, three. So this is the list. This mission is designed such way that it will support all 17 SDGs. For example, goal number one is no poverty. This will be done by providing high skill jobs and new industries. Or also the mission will fundraise. Then second one is zero hunger. The aeroponics for the sustainable food production, which eliminates the hunger. And then good health and well-being. The health will be assisted by the AI and bots. So this helps in good health and well-being of the crew. Then considering quality education, uh, the crew members will continue learning with AI and YouTube playlist provided. Uh, it also highlights gender equality as equal facilities and opportunity will be provided for both crew gender, male or female. Then clean water and sanitation. So we have water recycling systems in it. It is also affordable and clean energy, and all other uh, further SDGs is provide all of them. So this is I would like to introduce you to with ISRO latest mission. So ISRO is India's own space research organization, and recently on 13 December 2024, detected a crop soil experiment in space. For the first time, India have successfully germinated seeds in space, and it was a huge achievement. And it was a part of PSLV C60 mission. And the seed were successfully sprouted within 4 days under the microgravity conditions, which proved the feasibility. And it is also the most crucial part for future long duration space missions. This is the actual footage of the time lapse of the seed germination by ISRO. And this is the now I am representing my own greenhouse model, which I designed to be compatible with Starship because right now it's the best choice for heavy payload Mars missions. So we will choose a cylindrical layout. The module will be in the cylindrical design, and the diameter is 9 meter and the height 18 meters. As specific, the Starship payload size is this much. Its diameter is 9 meter and height is 18 meters. So it is compatible and it maximize the space utilization within the payload bay of Starship. And this vertical stacking arrangement make the module most efficient one. So it will be done in vertical layers and it consists of four layers. First one is light and radiation. As we know that in space we provide artificial lights through grow lights and other methods. Then in second layer is for aeroponic chambers in which sensors, air and bots will be used. And also the plants will be grown in this layer. Then in third layer, there will be living essential room. So for the crew members, there will be dormitories, kitchen, 3D printers, and other equipments. And the final layer is waste management, where everything will be recycled and can be reused. So this is how the greenhouse supports all other stations. For the main station, it provides oxygen, fresh food, and reduced storage dependency. For power station, it produces biomass and also regulates temperature. For in health center, it improves nutrition and immunity for crew members and reduce their stress and depression levels. So in engineering center, it can recycle CO2, maintain air stability, and benefit uh, support technologies. And it can basically control temperature and pressure levels in the engineering center. In launch center, it can supply emergency food packs for as a, and also operate as a backup supply. And in sanitation center, the organic waste can be recycled into compost and can be used in water by biofiltration. So this is actually my model. So this is the 2D illustration in the square form, and this is actually how it will look in the starship. So you can see all the four layers. There will be lighting, then plant chamber, then crew chamber, and then finally waste management system. And this is the three how it will be in the cylindrical form. So this is the concept how it will look in the starship. The visualization, as seen, it fits perfectly as the dimension of the starship payload is 9 meter in diameter and 18 meters in height. So it fits perfectly and it consumes all the uh, size perfectly. So we took a maximum benefit of the system. So now you can ask your doubts if any.